So in this video, we're going to compare two of the most common methods used to find magnitude and resultant of concurrent forces. So let's begin. So all the working out will be done on these two tables just so that we can have a fair side-by-side comparison. So at the end, what I would love for you to do is to leave in the comment and let me know which one of the methods you prefer. So on the left, the method that we're going to use is the reflex angle method. So on the right hand side, what we're going to use, I'll just label it as the horizontal referenced angle method. Okay, so let's begin. So just for clarity, on this first column, that's going to be our forces. And then the column in the middle, that's going to be the horizontal components. And the column at the end, that's going to be the vertical components on both of the tables. So if we start from the 8 kilonewtons, so that's the first force we have that's going up and to the right. Now, this is going to be quite similar for both methods because the differences really start as soon as we go greater than 90 degrees for the two methods. So for this one, if we look at the 8 kilonewtons, it's going up and it's going to the right. And the angle that we have there is 30 degrees between the 8 kilonewtons force there and the horizontal reference line. So if we follow our convention whereby for horizontal components, I'll put HC for horizontal component, where we did previously force, cos, and then the angle. And for vertical component, it's very similar, but it's the force, sin, and then our angle. So when we're doing the reflex angle method, we only measure the angles in a counterclockwise direction. So for example, this 30 degrees, it's just gonna be as is. So for the horizontal component then, it's going to be 8 and cos 30. The vertical component, it's going to be quite similar. So it's just going to be 8 sin and 30. And of course, we need to work out these values. So for 8 cos 30, 6.93. And 8 sin 30, that's just going to be 4. Now, what you will notice is, again, when we are working with angles that are lesser than 90 degrees, and in the first quadrant here, right there, both of these methods will basically be identical. So over here for the horizontal reference angle method, that's the same 8 kilonewtons for our force. And we'll have the same 8 cos 30, which gives us 6.93. And likewise 8 sin 30, which gives us the same 4. Now, this is where the two methods start to separate themselves from each other. And this is where you will start to see sometimes where you might make some mistakes with one method versus the other. So for the reflex angle method, each time I carry out a calculation, you're going to see where I draw in the angle on the diagram itself. So look at this here. So the angle is measured from this reference line there. So from the right and counterclockwise, and we're going to go all the way around to this 10 kilonewtons. That's the next force that we're going to evaluate. So all the way around to that 10 kilonewtons. And what happens here is we have to add that 90 degrees right there, to that 30 degrees. And that's going to give us 120 degrees. So what we do then with this reflex angle method, we would just need to write in 10 and cos 120. And that's it. 10 cos 120 will give us -5. And if we do the same thing for our vertical component, we will just end up with 10 sin 120. And 10 sin 120 will give us 8.66. Now, this is where the two methods start to separate, because for the horizontal reference angle, let me just clear the angle here. For the horizontal reference angle, what we're doing, we need to use the angle between our force and this horizontal line there. If you could just imagine that red or orange dotted line being extended, that's the one we're after. So we have to work out that angle there. So if we have 30 degrees plus 90 degrees there, and those two add up to give us 120, it means that the angle right here is 60 degrees, which is what we have to use. However, we now need to take into consideration the direction of the force itself. So when we're interpreting this for the horizontal force component, if our force is going to the left, as this one is, it's going up and it's going to the left, then any force component for the horizontal part needs to be negative if that force is going to the left. So what we would have to have here is now negative 10 cos 60. And if you were to put both of these into your calculator, you will realize that they give the same answer. Negative 10 cos 60 will give us the same negative 5. But the biggest difference is, for the horizontal referenced angle bit, you need to include the sine. Whereas if you were to use just the reflex angle method, there is no need to include the sine. So that's the biggest difference here. Now for the vertical component here, because this force, this same 10 kilonewtons, it's going upward, then we just need to use 10 cos 60 because that wouldn't be a negative force. And if you put that in your calculator, we'll still get that 8.66. So both methods will give you the same answer, but the approach is vastly different. Now, if we go across then to this 5 kilonewtons, because that 5 kilonewtons, it's just an horizontal force. It's just going to the left. So when we write this one in, so let's just put that force in. So that's the 5 kilonewtons. And because it's just going to the left, we just need to write this in as just negative 5 for our horizontal force component. Now it doesn't have any vertical component, so therefore this will be 0 right here. And the same thing will happen over on this side for our horizontal reference angle. This 5 kilonewtons, it's just a negative 5 because it is only an horizontal force that's going to the left. So the vertical component then again will be 0. So far we only have one major difference, and we're going to see where that plays out again in this next part, even more significant. So let's have a look at the 11 kilonewtons. So for the 11 kilonewtons here, we can see the angle between that 11 kilonewtons and the horizontal line there is 60 degrees. That's right there. So if we were to do the reflex angle method, all we would need to do is just to add that 60 degrees to 180, because 180 degrees on a straight line there above that 60 degrees, that would just give us all of that bit and add the 60 degrees to get that 240. So this now will just be 11 cos and 240. And when we put that in the calculator, because this force is going to the left, we expect that this will be a negative answer, which it is. We get this as negative 5.5. And we do the same thing now. We just put 11 sin and 240. And of course, negative answer we expect here because it's going downward. So this would just be negative 9.53. Now, the key difference again, which I want to highlight, is for the reference angle method here, the horizontal reference angle method, we're going to use that 60 degrees angle there. But what we have to do, we have to include the signs ourselves. So you have to be conscious of what the sign should be, whether negative or positive. So let's get that bit done. So this would be, it's for the horizontal component here, the force is going to the left, so we would have negative 11 and cos 60. And if you put negative 11 cos 60, you'd get the same thing as we did before there, which is negative 5.5. And of course, it's going downward. So for the vertical component, it's just negative 11 sin 60. And we get the same thing as we just did, which is negative 9.53. So I hope you can spot the key differences. One method, we need to ensure that we pay close attention to the direction of our vectors and ensure that we add the negatives, the positives. Whereas for the other method, that's the reflex angle method, as long as we get the angle correct, there is no need to consider what sign we should include, because that will take care of itself ultimately. So let's go to the 9 kilonewtons now. Hope you're still following. And if you are, then it would be really fantastic to have you subscribe to the channel and give the video a thumbs up if you like it. So for the 9 kilonewtons then, this force, it's going to the right and it's going downward. But for the reflex angle method, we don't need to consider that. We just need to get the angle correct. And if you look here, so in fact, I'm going to demonstrate this one properly or even better before we do the calculation. So I'm going to just draw the angle symbol in so you see exactly what we're measuring here. So it would start from this point here, and because we're going around to the 9 kilonewtons, we'd have to measure all of this angle going all the way around right there. And if the angle between here is 60 degrees, then we would expect that everything else would be just 300 degrees. So that's for the reflex angle method. So let's go ahead with the rest of the calculation here. So then we would end up with here 9 cos 300 degrees. And 9 cos 300 gives us 4.5. And we do the same thing, 9 sin 300, and that gives us negative 7.79. And the reason why one is negative, the other is positive once again, if the force is going downward, then our vertical component, the answer must be negative. If the force is going to the right, like this one is, so it's going in a downward direction and to the right, then the horizontal component would be positive. So if we go across to the next method, as you can expect, we have to ensure that we include the appropriate signs. So for this one, the reference angle that we use is 60 degrees. So we would have 9 cos 60 here, and 9 cos 60 would give us the same thing as 9 cos 300. So this here would just be 4.5. Then now, when we go across to the downward bit, which is the vertical component, we have to ensure that we include the negative bit. So this needs to be now negative 9 sin 60, which is going to give us the same as 9 sin 300. So this now is negative 7.79. And of course, if you get to this point, you now need to find the magnitude and the resultant of the force components. So let's do that now since we get to this point and complete the entire question. So what we would have to do now, we would just sum up our column here for the vertical components, the horizontal components, and I'm just going to sum one column because we have the same values here. So for horizontal components, we get negative 4.07, and vertical component, negative 4.66. And it would be the same answer on the next table. So no need to sum that up. Let's just go through the motion of finding the magnitude and the resultant now. So when finding the magnitude and direction of the resultant force, the advisable thing to do is just to sketch this on a coordinate grid, just like so. It doesn't have to be perfect. In this case, I'm just literally demonstrating. So vertical component goes there, horizontal components goes there. And because both of these are negative, it would lie in this quadrant. So for the horizontal component, our negative 4.07 would go there. and our negative 4.66 would go there for vertical. So it means the force would be acting like that. And then our angle would be right there that we're trying to find. So this is our resultant. And of course, for the resultant, it's just square root, and we want to square both of those values we got. Don't need to include the negative, because if we square them anyways, it would just be positive. So just square both of these, square root our answer. And the resultant here is 6.19 kilonewtons. And of course, our angle is going to be tan inverse. And we use the vertical component, so 4.66, over horizontal component 4.07. And of course, our angle is 48.87 degrees. Now, I've done both of these methods separately. So if it is that you want to dive deeper into any one of these methods, then on the left hand side here, you will find the horizontal referenced angle method. And on the right hand side here, you will find the reflex angle method. So feel free to check any one of those videos out. And until next time, have fun practicing.